All right, so we were talking about square roots with limits. So if you have the square root of x plus 7 minus 4 all over x minus 9, and you try to plug in 9, you get the square root of 16, which is 4 minus 4. So you get 0 over 9 minus 9 is 0. So you have 0 over 0. This is called an indeterminate form. So 0 over 0 isn't necessarily does not exist. There's usually some kind of trick, like factoring or multiplying by a conjugate or something that works. So we talked the last time about a conjugate. So you remember in Algebra 2 when we had like 2 plus 3i on the bottom, we multiplied by 2 minus 3i, right? Or if we had 2 minus square root of 3, we multiplied by 2 plus the square root of 3. It's the same idea for limits. We did it on top and bottom. I guess I should write it out on top and bottom. So if we have a square root and a limit, and you notice that you try to plug in the number and you get 0 over 0, or undefined, you're going to multiply by the conjugate. So we're going to multiply by the square root of x plus 7 plus 4 all over the square root of x plus 7 plus 4. So it doesn't change anything. I'm multiplying by 1, right? Same thing over itself. So when we do this, we have the limit as x goes to 9. And we FOIL out the top, but we usually leave the part that doesn't, like the outer and inner don't cancel. I leave that factored. So x minus 9 times the square root of x plus 7 plus 4. Because a lot of times some magic's going to happen where you can cancel things out, right? All right, so as we FOIL, we take the square root of x plus 7 times itself, so we get just plain x plus 7. And when we do the outer and the inner terms, we have 4 times the square root part, and then we have minus 4 times the square root part. So the outer and inner cancel. All right, then we have minus 4 times 4. Now be careful, those weren't under square roots, right? So minus 4 times 4 is going to be minus 16. And if you did it correctly, you'll know that you did it correctly, because as you can see, on the top, we get x minus 9. And that's what we want, because we have an x minus 9 on the bottom. And that's what's making it undefined, right? 9 is the number we're trying to plug in. So when we cancel out the x minus 9, the part that was making it 0 over 0 is now gone. So now we are able to plug in 9 without getting undefined. So when you plug in 9, we still have a 1 on top, and then we have the square root of 16 plus 4. So we get 1 over 4 plus 4, which is 8. So 1/8 is our answer. Does that make sense? All right, so the next trick we're going to learn about is common denominators. So if you notice that you have a bunch of, like, you have a complex fraction, a fraction within a fraction, what we're going to do is we're going to multiply by 4 over 4 on that first fraction on the denominator, and we're going to multiply by x plus 4 over x plus 4. So we're going to try to combine everything as much as possible to simplify this big fraction and hope that the part that was making it undefined is removed. So you see how you can't plug in the negative 4 because you have 1 over x plus 4. Yes, Jack. Okay. All right, so when we do that, we have the limit as x goes to negative 4, and then we have x over, guys, stop talking back there. So we get 4 over 4 times x plus 4 minus x plus 4 over 4 times x plus 4. So we get the limit as x goes to negative 4. And we're combining that denominator. So we have the same denominators. We have 4 times x plus 4. So we combine them into 1, and we have 4 minus parentheses x plus 4 all over 4 times x plus 4. So I've been doing this a long time. Every single year I say this. It's one of those things that I say repeatedly year after year after year, and then people still do it. Okay, you have to have parentheses right here. If you do not put the parentheses there, then when you subtract, you're going to forget to distribute that negative, right? So put parentheses and remember to distribute the negative. So now what we have is the limit as x goes to negative 4. And we have x, and I'm going to write divided by, like the little obelisk sign, divided by. The top becomes 4 minus x minus 4, and the bottom is 4 times x plus 4, which you can write as 4x plus 16, or you can leave factored. It doesn't matter. So when you have the 4 minus x minus 4, the 4 and the minus 4 go away. So now you have the limit as x goes to negative 4, and you have x times, so when I had divided by a fraction, I'm going to multiply by its reciprocal. I'm going to flip it. So I'm going to have 4 times x plus 4 all over negative x. So the x and the negative x reduce out. You still have a -1 though in the denominator, which you could put on the numerator if you want to. It doesn't matter. Now can you plug in? Yeah. So you plug in the -4, and you get 4 times 0 over -1. Is that okay? Yeah, this limit is 0 then. So a limit can be 0. Don't get 0 and think, oh, I can't have that. Undefined, doesn't work. D&E. It does work. 0 is a number. Okay, if you had like something over 0, that's when we have a problem. All right, so sometimes it's easiest to calculate limits by first finding the left-hand limit and then finding the right-hand limit, or by graphing. Remember that the limit as x goes to a of f of x equals L if and only if the limit as x goes to a from the right of f of x equals L, and the limit as x goes to a from the left of f of x is equal to L as well. So you have to have your right and left-hand limits going to the same y value. Okay, this part right here should be over here. I got moved over. So it says prove that limit as x goes to 0 of absolute value of x equals 0. So you could do this 2 different ways. The easiest way, I think, is to just use your knowledge of what the graph looks like. Do you guys all know what the graph of the absolute value of x looks like? Yeah, it's just a V shape, right? So if you use your knowledge of the graph, you know that the graph hits 0 and bounces back up, right? So if you talk about the limit as x goes to 0 of the absolute value of x, right, as you trace your fingers, so your right hand and you're tracing closer and closer and closer, and your left hand and you're tracing closer and closer and closer, what y value do they both go to? 0. That's easy. That's probably the easiest way to do it. Okay, another way you could do this, and with any absolute value you could do this, is you could think about what it's equal to. So if you have the absolute value of x, it's really a piecewise function. Okay, this line right here is y equals x. So we would have x if x values are greater than or equal to 0. But this line right here is y equals -x. So we'd have -x if x is less than 0. Does that make sense? So if you plug in a negative number, like -5, you get -5. You get +5 out. That's what we're saying. So then you could come up with the left-hand and right-hand limits for each of those. So you could say, well, the limit as x goes to 0 of just x is 0. And then, sorry, I should say from the right. And the limit as x goes to 0 from the left of -x is also 0. Therefore, the limit as x goes to 0 of the absolute value of x is also equal to 0. So see how you can take one piece of it and then the other piece of it and show that they go to the same. Okay, that's a little bit harder. So when do we use that? We would use that if we had, like the limit, don't write this, but kind of pay attention. If we had absolute value of 2x minus 1, maybe. Maybe we could write it out, but you could also just graph it. But you would say, oh, well, that's a piecewise function. It's 2x minus 1, and it's negative parentheses 2x minus 1. And you could find the limit for each thing. All right, so the next one. I guess it wouldn't be as x goes to 0, it would be x goes to 1/2 in that case. All right, so if f of x equals the piecewise function, so the square root of x minus 3 if x is greater than 3, and 6 minus 2x if x is less than 3, decide if the limit as x goes to 3 of f of x exists. So when we have a piecewise function, if our limit, as we go to the value that they have in common, in order for it to exist, they have to go to the same y value, right? You can't have like one graph going to here and another graph going to here. The limit would not exist at that point. Does that make sense? Okay, so we're going to talk about the right and the left. And you could just sketch a graph. This graph is a pretty easy one. Do you guys know what the absolute value of x looks like? If I just did, or not absolute value, square root of x. What does square root of x look like? Yeah, exactly. It's like a curve like this. So if I have the square root of x minus 3, use your knowledge of transformations, where does it shift? I see Bronwyn moving her finger to the right. Right 3, exactly. Oh, I shouldn't do a little open circle there. Or I shouldn't do a closed circle, I should do an open circle. So it's going to look like this. Now the other one is 6 minus 2x, which is going to go 1, 2, 3, 4, 5, 6. And you're going to go down to right 1, down to right 1, and so on. So it's a line. If you plug in 3 to 6 minus 2x, do you guys see how it would be at 0? So it's going towards this point, but it doesn't fill in the point because it's still just a x is less than, not less than or equal to, so we don't fill in the point. Does the limit exist? Yes. So even if it's an open circle, as you trace your fingers from the left and the right and go towards x equals 3, do you guys see how they're all going to 0? So that is the limit. So the limit as x goes to 3 of f of x is equal to 0. That's our answer. Okay, so we do have 2 special trig limits. You will need to memorize these, just like Mr. Bradley tells you to memorize AP US history stuff. I tell you to memorize things as well. No one writes it in on a note card for math. I don't know why. You should have note cards for AP Calc. So this is one of them. So limit as x goes to 0 of sine of x over x equals 1. And the other one is limit as x goes to 0 of 1 minus cosine of x over x equals 0. Okay, so these are interesting limits. You need to know both of them. We're going to use them in these next couple questions. So the first one says, find the limit as x goes to 0 of tangent of x over x. So it doesn't look like either of those limits. Okay, so we try to get it into one of those forms. So what do we know tangent is? Tangent of x is equal to what? Sine over cosine. So we're going to use that. So we're going to say the limit as x goes to 0 of sine of x over cosine of x, and I'm going to say divided by x, like that. So that's going to be the limit as x goes to 0 of sine of x over cosine of x times 1 over x. So I'm going to sneak the x in on the denominator with the cosine. So it's x cosine of x. Not cosine of x squared. A lot of people try to do that. Right? X is just in front. All right, and we're going to use those limit laws. So I went very speedily through limit laws. Okay. With limit laws, all we're going to do is we're going to break it apart. So we're going to say limit as x goes to 0 of sine of x over x. And then we're going to multiply by the limit as x goes to 0 of 1 over cosine of x. And one of those is something that I told you should memorize. So I said if you have sine of x over x, the limit as x goes to 0, that should be 1. And the other one we're going to try to plug in for. So if I plug in 0 into the second fraction, I have cosine of 0. Is that 0? No. Cosine of 0 is what? 1, right? Think on union in a circle. It's 1. So we end up getting 1 times 1, which is just 1. So it works out. It's 1. A lot of people will try to say cosine of 0 is 0. It is not. It's 1. All right. So there is some confusing stuff. But then it gets really easy because I'm going to show you a shortcut. So I'm going to show you a little confusing step with substitution, and then we're going to talk about how this can be easier. So it says use substitution to compute the limit as x goes to 0 of sine of 9x over x. Okay, so we identify that we have something strange. We have sine of 9x instead of just sine of x. So what we do is we let w equal 9x. So what we really have, instead of sine of 9x over x, is we have sine of w over, how do I replace x? What do I replace it with? W over 9, exactly. But I don't want to have the limit as x goes to 0. Let's think about it. If I have x goes to 0, doesn't 9x go to 0? So if x goes to 0, that means 9x goes to 0, which means w goes to 0. So I'm going to replace x goes to 0 with w goes to 0. Because if x is going to 0, then 9 times x is also going to 0. So we're almost in the form we want, except we have that weird over 9 thing. So how does this simplify? Like, where does the 9 end up going? So we have limit as w goes to 0. Think about it. If I have sine of w, sine of w divided by w over 9, I flip that w over 9. To become 9 over w. See how it becomes a 9w, or a 9 sine of w on top, and then a w on the bottom. Does that make sense? So we get the limit as w goes to 0, and we can actually pull out the 9. So I'm going to pull it out front here. And then I'm going to have sine of w over w. That was another limit law where you can pull constants out. So now this is the part that was important to us. What is that? 1. So we have 9 times 1, which is 9. Okay. So there's going to be a pattern. Let's try one more and see if we can figure out the pattern. Now, I told you that the special trig limit, we had limit as x goes to 0 sine of x over x equals 1. The limit as x goes to 0 of x over sine of x is also equal to 1, right? It's just the reciprocal. It's also 1. All right. So this one says compute the limit as x goes to 0 of 6x over sine of 5x. Okay, so what's our w in this case? W would be not 6x. It's the part you're taking a sine of, right? So it's going to be 5x. So we're going to let w equal 5x. So that means that if x goes to 0, then w is also going to 0, right? 5x would go to 0 as well. So we're going to have the limit as w goes to 0. And then I have 6x. What do I replace x with? X is w over 5. Do you guys see that? We're just dividing the 5 over. So we get the limit as w goes to 0 of 6w over 5 divided by sine of w. So it becomes the limit as w goes to 0 of 6w over 5 sine of w. So what happens is that 6/5 can just go to the front. So we have 6/5 limit as w goes to 0 of w over sine of w. And I told you that part, even though it's the reciprocal, it also goes to 1. So we end up getting 6/5. Do you guys see a pattern? So like number 3 went to 6/5. Number 2 went to, we'll go back. It went to 9 over 1, 9, right? What do you think this next one, number 4, is going to go to? 7 over 4. That's all it is. So when you see something like that, don't do all the work. You know this. You should get it in like 1 second. So these will pop up on the multiple choice all the time. In multiple choice questions, you're allotted about 2.3 minutes for each multiple choice question. This is one that saves you time, right? When you look at that, you're just like, oh, 7 over 4, done. But I warn you, be careful. Because what about this next one? What is different about this next one? Right, x is not going to 0, it is going to infinity. So this is actually what you guys had on your homework the other day. So this is where we say sine of x is sandwiched between 1 and -1. As x goes to infinity, x would be a positive number then, so we're allowed to divide everything through by x. And the limit as x goes to infinity of -1 over x, well, that's going to be 0. Think about plugging in like 100, 1,000, 10,000, and so on. It's getting closer and closer to 0, 1 over a big number. And the limit as x goes to infinity of 1 over x is also 0. So by the squeeze theorem, the limit as x goes to infinity of sine of x over x is equal to 0 as well. Okay, does that make sense? All right, so that's the end of that section. So you guys know all the tricks now. So you know how to factor, you know how to get common denominators, you know how to multiply by a conjugate, you know the sine of x over x goes to 1, right? You know all of the different tricks. Post that last